Very good morning. In this video, the information regarding that seed production technique for variety and hybrid will be given. So first we can see the seed structure of the sorghum. So that will give some idea regarding that suitability of the sorghum for various persons. So that sorghum also a monocot seeds, albuminous nature, that is that have a endosperm, well developed endosperm. The major portion of that seed is occupied by the endosperm and a smaller area is occupied by the embryo. In the case of sorghum, that have a different type of endosperm. So that different type is mainly based on the chemical constituents of the endosperm. In some of the cases, some of the variety, the endosperm is called as a floreus. In some of the cases, call it as a corneus. In some of the cases, a combination of floreus and corneus. In the case of the variety with floreus endosperm, that have only that carbohydrate alone, so that totally divided up any fibrous matter. So that kind of variety and all very much suitable for consumption for the person not having the diabetic problems, or that will be very much suitable for that young children's, because that have only that carbohydrate that is easily digestible. There won't be any problem with reference to digestions, and also we can make use of that material for preparation of some dry items like your popcorn. That kind of things also sometimes possible because of sorghum. For raw eating we can. That corneas means that have more of that fibrous matter, so more of fibrous matter. So for digestion of that kind of variety, our system need to spend some energy. So because of that, these particular kind of variety, that is a variety with the corneous endosperm, is a recommended item for the person having the diabetic problems. If anybody wanted to lose their energy, or anybody wanted to do the consuming activity as a work, better they can consume the sorghum variety with the corneous endosperm. So in this case you cannot have that puffed kind of things and all, you cannot prepare. The variety with the corneous endosperm means the puffed sorghum grains and all we cannot prepare as snacks, whereas that is possible only in the case of a variety with the floreus endosperm. So these are all the some general items regarding that sorghum seed and their uses. And this also have a well developed aileron layer, so that aileron layer that play a huge role at the time of that germinations, because that as a signal of that germination initiation process, the seed will activate that GA3 production. That GA3 diffused through the aileron layer, that will enter into the endosperm. There that will activate the hydrolytic enzyme production. So that is a process normally occur during germination. So in this angle, the role of aileron layer is very important in the case of that sorghum also. So these are all the information about that sorghum seeds. So this is regarding that plant morphology. So here that this also have a ear head and a leaf and a single stem, so no tillering ability. If at all any insect infestation, at the time only that tillering will occur. That tiller occurring leads to that yield reduction. So these are all the things with reference to that plant. Now we can see that floral structures. So this have normally before. So this have the well developed stigma and gynoecium and anther. So the anther number and all three numbers of anther will be produced, and this is the ovary part, and the earhead will appear like this. So more number of flowers will occur. And another main thing with reference to that sorghum flowering is concerned, so that sorghum flower occur always in a pair. In a single pedicel, a pair of flowers will occur. Here you can see. So this one flower, this is another flower. Actually this one is a pedicellate flowers, the small one is a pedicellate flower, the another one is a sessile flower. The pedicellate flowers are mostly it's a male sterile, as a sterile or male fertile. Okay, it may be a male flower or a sterile one, whereas sessile one is a bisexual nature, so that will have both gynoecium as well as anther. So this is a open flower of that sessile one. So here you can see that anthers as well as gynoecium, everything is available. So here that flowers occur always in pair. So one is a pedicellate flower, another one is a sessile. The pedicellate one is a male fertile or sterile nature. So this is a thing with reference to that sorghum floral biology is concerned. So again, this particular crop is a often cross-pollinated crop. Reason for occurrence of that often cross-pollination in sorghum is decided by the receptivity of the stigma. So normally that stigma that will attain receptivity 2 days before flower opening. So 2 days before flower opening, the stigma attain receptivity. At the time, there is a chance for occurrence of the self-pollinations. So more chances are there for occurrence of the self-pollination. During that 2 days period of time, the stigma are not yet attained, that not undergo that pollination fertilization process, means even after that flower opening also the stigma going to remain receptive for about more number of days, for about minimum of 5 number of days. So during that time there is a chance for occurrence of the cross pollinations. Okay, so because of that, these particular crops, sorghum is placed under that often cross pollinated category. And regarding that sorghum, that earhead or different type of earhead structures are available. Some of the variety that will have a compact earhead, some other things it's a compact, a semi-compact, some other cases it's a loose panicle. So entire panicle is not compactly arranged, that will appear like a loose hair of the girls. The very good example for that variety with the loose panicle is Thalaivurichan cholam, that is in Tamil. So the variety that have a loose panicle means there more chances are there for occurrence of the cross pollinations. The variety with the compact panicle means there that self pollination is promoted. So this and all decided by the floral arrangements and the panicle type. So that is a thing. And flower opening normally starts after 2 to 4 days of that panicle emergence. And flower opening also basic petal nature, like that of your rice. And flowering period is for about 7 days. Whereas that pollen viable for only 10 to 20 minutes, so a short period of viability, but the stigma remain receptive for longer period of times. And flower opening and this is normally occur between 2 a.m. to 8 a.m. If at all anyone wanted to pollinate the female parental line artificially, means they have to collect the pollen grains from the male parent, and they should be available in the female plant nearer to that female plant by 2 a.m. So this is the one difficulty faced by the breeders. They must be there in the female parental line field by 2 a.m. in the night. Okay, so that's the thing, because this flower open between 2 a.m. to 8 a.m. Regarding the stages of seed multiplications, so both for variety and hybrid we are following that 3 generation systems, because for varietal seed production is often cross pollinated, so chances are there for occurrence of the 30% cross pollination. So because of that, here we cannot follow 4 generation or 5 generation like that of the rice and groundnut. So here we have to follow 3 generation systems. Varieties are multiplied through controlled open pollination process by following breeder seed, foundation and certified seed. Certified seed is distributed for grain production purpose. For hybrid seed production purpose, here we are following that cytoplasmic genetic male cell system like that of the rice. So now we can discuss about that varietal seed production and later requirements. So the land requirement for varietal seed production sorghum is whatever the land selected, that should be free of any volunteer plants, and the field should have that well drainage facilities. So these are all the very important thing. Apart from that, the selected land should not be cultivated with other variety of the same crop in the previous season. That also we have to ensure. Then season, the best season for varietal seed production sorghum is November, December if it is a Rabi season crop. If it is a Kharif season crop, 4th week of June to 1st week of July is ideal. The main point here is that the flowering and maturity should not coincide with the heavy rainfall. That is a very important thing. Particularly the flowering period should not coincide with the that heavy wind as well as that rainfall. So if at all these things are coincide, so there is a loss of pollen during that flowering time. If maturity is coincide with the rainfall, definitely the moisture content of the seed will be increased. That seed will be amenable for attack of all the pests and diseases. So that is a problem in the case of that sorghum seed production is concerned. So accordingly we have to select that season and go for that planting, taken up sowing of that seeds, sorghum seeds for seed production purpose. Regarding that seed rate, here we are recommending the farmers to follow that transplanting operations, because in this the case of sorghum the major problem is shoot fly. So here you can see this is a shoot fly. So the shoot fly normally causes problem in the seedling stage. So that will causes problem to the sorghum seedling. So that occur in the early stages. If at all that shoot fly incident is there, that will be eaten away that primary primaria, that initial that stem, tip of the stem will be eaten away by the shoot fly. Once that apical bud is removed, automatically that leads to occurrence of that side shooting. So the side shooting is not a ideal one, so that ultimately reduce the yield of your crop. So because of this particular issue is there, we have to follow that transplanting operations, because for transplanting purpose we have to raise that seedlings in the nursery. So after attainment of that age only we will go for the transplanting. So during transplanting, if at all that seedling have the problem of the shoot fly, there itself you can reject only good quality, that is the seedling totally divided of the shoot fly incidents alone we can transplant in the main field. So by that way we can overcome that particular problem. But if you follow that direct sowing, if at all any shoot fly incidents, so there will be a gap in the main field. So after that you have to go for that re-sowing. So if you go for that re-sowing, the capping through capping operations, so whatever that seeds sown in the later period, that never match up with the growth and development of the initially sown seed and their resultant seedlings. So one will be at a vegetative, one will be at a flowering, like that some difference in growth will be recorded. So that are not accepted by the seed certification officials during their inspection time. So all these things will create a problem for our seed production operation. So to avoid that one, better we can follow the transplanting operations. And also once you say this is a seed crop, that should have adequate irrigation facilities. We should not take up that seed production operation and all in the rain-fed area. Okay. So because of that, the right way of doing is that irrigated transplantation work we have to follow. So under irrigated conditions you are going to do that transplanting, means there we have to use 7.5 kg per hectare as a seed rate. Under rain-fed conditions you are going to take up sowing directly, means we have to use 10 kg per hectare. Under rain-fed condition we can do only the direct sowing, so there we have to use excess quantity of 15 kg per hectare. So there we have to use the seed rate of 15 kg per hectare. So that is a seed rate requirement. And then another important thing as far as the sorghum variety seed production is concerned, maintenance of the isolation distance. So here for varietal seed production purpose we have to maintain 200 meter isolation at the foundation stage and 100 meter isolations during that certified stage. So this is somewhat lesser than the maize and more than the rice. That is mainly because these particular variety pollination behavior put it in between that rice and maize. Maize is a highly cross pollinator, rice is a self pollinated. So whereas that sorghum is a often cross pollinator. So because of that, the isolation distance also in between rice and maize. Rice is less, whereas maize is more, but sorghum in between these two. That is a 200 and 100. Maize for varietal seed production we are recommending 400 meter and 200 meter. So we have to use authenticated seed material for sowing purpose. Suppose you are going to follow that direct sowing, means the depth of seeding should be 3 to 4 centimeter. So here also we have to follow that thumb rule. So the sowing depth should be 2.5 times the width of the seeds. So here that 3 to 4 centimeter we have to follow. That spacing also 45 into 15 centimeter. So before sowing, the seed must be given with seed treatment. So this is mainly to make your seed to perform very well under the field conditions. Mostly the sorghum is cultivated under rainfed conditions in most of the places. Water may be either for its grain purpose or seed purpose. The farmers, they are cultivating these particular crops under dry land as well as that rain-fed conditions. Once you decided to take up that sorghum crop cultivation under rain-fed condition, means the seed must be given with hardening treatment. Hardening treatment means it's a soaking and drying of the seeds. So by the way of soaking the seeds either in the water or any nutrient solution, particularly in the case of sorghum, we are recommending 2% potassium dihydrogen phosphate solutions. So by the way of soaking the seeds in the farmer holding itself, we are making the seeds to initiate the germination related process. Initiate the germination related process like imbibition, GA3 production, hydrolytic enzyme activation, conversion of complex carbohydrate into a simple sugar. As and when that complex material is converted into a simple sugar, we have to stop the germination related process. We should not permit the seed to move to the next step like glycolysis and embryo elongation and rupturing of the seed coat. So as and when that seed converted all the complex material into a simple material, all those materials are ready for that entering into the glycolysis, means there we have to stop. So for stopping that particular process, what we have to do is we have to remove the seeds from the nutrient solution and go for drying. So during drying also we have to follow certain principles, because the seed is now have more amount of water. So the water content may be of more than 40%. 40% means all the three forms of water will be available in the seeds. Normally in living systems, water will be available in the three forms. So all the three forms may call it in a different name like a free water and bound water, adsorbed waters. The free water that are all available freely, not held by any forces. So physically that is available. Adsorbed water, that is get absorbed on the surface of the seeds, very weakly held. So very weakly held by the seed structures and organelles of the seeds. Whereas bound water, it's a part and part of a chemical constituent of your seeds. I can give you an example. In the case of magnesium sulfate, MgSO4.2H2O, like that we used to write. .2H2O means water is not a separate entity, that is a part of that magnesium sulfate. If you disturb that .2H2O, automatically that magnesium sulfate property will be lost. So that is normally known as a bound water. Similarly, in the case of seed also, that kind of water is available, that is a bound water. At any cost, we should not disturb that kind of waters. The bound water should not be disturbed during your drying process. So at the end of your soaking process in the hardening treatment, your seed will have all the three types of water. And now we have to stop that germination related process as and when that attain that conversion of all the complex material into a simple material. Or otherwise that process will continue, the soaking bucket itself, that the seed will germinate and that root will come out of the seeds. So once that root come out of the seeds, at that level that material is sown in the field, that too in the harsh environment like rain-fed conditions, definitely whatever that root come out of the seeds will die immediately. Okay, so before emergence we have to stop that process. So for that purpose we have to reduce the moisture content. By the way of reducing the moisture content only, we can stop that further process of germinations. So again for drying also, here all the three types of water will be available. So that for removal of the free water, no need to supply any energy, because this is not held by any forces, like van der Waals force or any other forces. It's freely available, physically available. and adsorbed water alone held by the very weak forces. So for removal of that kind of water, minimum heat energy is needed. So minimum heat energy is needed, whereas bound water is an part and part of the chemical substance of that seeds. So this is very strongly held, and for removal of that one we have to apply excess amount of the heat energy, but we should not disturb that water. So already I told you the reason for why we should not disturb the bound water from the seed systems. So anyhow, now that moisture content is more than 30%, the seed going to be there with that level of 30%, definitely the germination later process will be continued. Within a short period of time we can expect that root emergence. So once that root emergence, we cannot use that particular seed for direct sowing purpose, whereas in the case of paddy we are using that pre-sprouted seeds. But that sowing condition and all, it's a very pakka. There we are going to prepare a field in a pakka manner, and also we are going to have a clay soil, well leveled one, and we will have that raised bed thing, and that soil surface is very smooth, very smooth and very soft, that will have a adequate amount of water. Okay, and that is almost equal to a water bed. There we can sow the seed, and that will have that free emerged seeds and all, we can sow. But here we are aiming for sowing of the seeds under rain-fed conditions. So here the water availability also a problem, and the field is not having a fine tilth. So under that condition we cannot sow the pre-sprouted seeds. So for that purpose only we are aiming. So now three forms of water available. Suppose for drying of the seeds, for reduction of the moisture content, if you expose the seeds to heat energy, what will happen? The water like pre-water and adsorbed water will try to escape. So there will be a competition among the three waters with reference to escape from the seeds. But available area is limited. That should be escaped through the pores available in the seed coat. So if you expose the seeds to higher temperature, the sunlight, so the sunlight will give you more heat energy. So that heat energy is supplied already. For removal of that the free water, no need to apply any heat energy, because not held by any forces. So if you apply that heat energy, the free water also will ready for escape, and adsorbed water also need minimum energy for escape. So that adsorbed water also ready for escape. So there will be a competition between the free water and adsorbed water with reference to escape from the seed, that too through that small pores available in the seed coat. So this competition leads to occurrence of some damage on the seed coat, that will causes some damage to the seed coat. So once that seed coat is damaged before emergence of your seedling, particularly the root, definitely that causes a problem to the life of the seed material, because once you sow the seeds in the soil, that damage the seeds in the soil, if at all the seed coat have a damage, the entry of the water into the seed is through that mass flow action. The mass flow action means uncontrolled way the water will enter, that will create anoxia, and that will kill the seeds. So water entry should be regulated through the osmosis process, that through occur in the seed coat. Without any damage, there only we can expect water entry through the osmosis process. If at all any seed coat damage is there, that water entry will be mass flow action. Mass flow action means water entry will be, it's unregulated, uncontrolled entry of water. So definitely that will cause us problem to the seeds. So that is a problem. So in order to have a seed with lesser moisture content and without any seed coat damage, we have to follow certain systems for drying of the seeds. So initially we have to look for removal of that free water. So for that purpose, what we have to do is we have to spread the seeds under dark conditions or shade conditions. And the only thing is that surrounding atmosphere, surrounding air, latent humidity should be lesser than your seed latent humidity. So the moist air should not be there in that particular drying in that areas. Okay, so somewhat warm. So that warm air is there. If you go for that spreading of the seeds in the dark conditions, there is a exchange of the moisture content between that seed and all that surrounding atmospheric air. Suppose that air latent humidity is less, automatically that will remove the free water available in the seeds there, and that won't donate any moisture to your seeds because already the air itself a dry one. Okay, so now here we are not going to apply any heat energy. So because of that, only that free water alone will escape. So lesser competition, only that free water alone will come in and that will escape. Once that free water is escaped, after that you can expose your seed to the sunlight, that too in between the 8 to 10 a.m. in the morning. So at the time little amount of heat energy alone that seed will receive. So that little amount of heat energy is sufficient to remove that absorbed water alone, because that absorbed water and all held by the very weak forces. So by the way of supplying minimum heat energy, so if you supply minimum heat energy at the time, that absorbed water alone is ready to escape, whereas bound water that is very strongly held by the chemical bonding. So for removal of that one, we need to apply more heat, but here we are exposing the seed to the morning sunlight. So because of that, that absorbed water alone will escape. So at this level, if you go for checking the moisture content, definitely the moisture content will be almost to that of the original level. So once that original level means that will be of 8%, and the initial seed moisture content will be of 8%. After soaking only that going to reach up to the 30%. Then after soaking is over, as and when that seed converted all the complex material into simple material, to stop the germination related process further, we are going for drying. So during the drying, we are going to follow that process. By that way, we are going to make the seeds to reach the original moisture content. So once you follow this process for your seeds, at the end of this process, you will have a seed that have the endosperm. That endosperm full of that simple sugar. If you sow that seeds in the rain-fed condition immediately after receipt of the rain, the seed will start its germination process from glycolysis, ATP generation, embryo elongation, and rupturing of the seed coat, but not from imbibition, GA3 production, hydrolytic enzyme formation, conversion of complex carbohydrate into simple carbohydrate, like that. So because all these processes already completed by giving that soaking treatment. So before sowing, all this process completed. Only we are going to sow the seeds with simple sugars. So if you do so, the seed will initiate the germination process from glycolysis, ATP generation, and rupturing of the seed coat and elongation and that coming out of that radical. So the main advantage here is, for occurrence of that glycolysis and rupturing of the seed coat, minimum water is sufficient. But for GA3 production, hydrolytic enzyme formation, and conversion of complex carbohydrate into a simple thing, that need more than 30% moisture content. Sometimes that demands 60% moisture content. But in the case of rain-fed, the problem is today we will receive the rain. Say example, today morning you are receiving the rain, means today morning that soil, the top layer will have adequate moisture content. By 11 or 12 p.m. there will be a heavy sunlight intensity. The soil will heat up, and that soil water will be get evaporated. The evening, that completely dry, that moisture content may be of 10 to 20%. But the farmers, what they are doing is, immediately after receipt of the rain, they will take up that sowing. So once they receive that rain by 6, means in the case of red soil and all, immediately we can go for the sowing. Today night they are receiving the rain, means next day morning they will take up sowing. At the time of sowing, the moisture content of the soil will be from somewhere around 40 to 50%. They can take up sowing. The seed also will initiate that GA3 production and hydrolytic enzyme formation. if at all any heavy sunshine in the afternoon or in the next day, at the time there will be evaporation, moisture reduction. If the moisture is reduced to the level of less than 30% or something, at the time the seed in the process of that hydrolytic enzyme production means the reduced moisture content, reduced soil moisture content will create a problem to the seeds. So the seed moisture content also will start to decrease. At the time, if at all the seed in the stage of that hydrolytic enzyme production means that hydrolytic enzyme and will get inactivated. So once that hydrolytic enzyme is get inactivated, it's a irreversible damage. We cannot by the way of giving water, we cannot make the seed to produce all the enzymes. It's a permanent death for the seeds. So that is a problem faced by the farmers. So because of that, we are recommending hardening treatment. So in that before sowing, we are making our seed to complete all these process. Up to before that glycolysis occurrence, we are completing all these process. So if you do so, and that if you follow that hardening, minimum moisture is required for occurrence of that glycolysis, and minimum moisture also very much needed for softening of the seed coat. Once that seed coat is have a contact with the minimum moisture, the seed coat gets softened. That is easy for the embryo to easily rupture the seed coat. Suppose that if it is a dry seeds, for rupturing purpose, that embryo need to spend more energy. Okay, so that is the thing. So these are all the advantage of that seed hardening treatment. So seed hardening, what we are going to do is, we are going to soak the seeds in the nutrient solution or water solution. That is mainly to induce that the seed to initiate the germination related process. So before that entry of the seed into the that glycolysis and that embryo elongation and upsetting of the seed coat, we are going to stop the seeds by the way of reducing the moisture content. And then up to that level, we are going to have the seeds in our hand itself. So as and when the rain occur, immediately we will take up that sowing. If we follow that one, there will be a success with reference to that crop establishment. There won't be any failure, and also you can get early emergence of the seedlings when compared to that raw seeds sown in the soil surface. That is, the seeds not given with any hardening treatment. So these are all the main advantages. So because of that, the seed hardening is a very popular treatment among the rain-fed farmers. So this is mainly to give some sort of a drought escaping mechanism or drought tolerance mechanism for the crop. So that sorghum is a rain-fed crop, so this is an ideal treatment. So for sorghum hardening purpose, we can use 2% potassium dihydrogen phosphate. So here that the duration of soaking is 12 hours. Again, that the duration of soaking will vary from crops to crop. Say example, the seed with more of fluorescence endosperm means there we have to give 12 hours of soaking. That is sufficient, because there that conversion will be very easy. Suppose that seed have that complex carbohydrate that is blended with fibrous matter means that will take more time for conversion of that fibrous matter into simple sugar and all those things. So there we have to extend the soaking time and all. So that is a principles. So everything is based on the chemical constituents and type of chemical stored in the endosperm. So that is a thing. That another treatment is, I already told you, that is a sorghum shoot fly is a major problem. So that causes problem during the early seedling stage. So to control that one, we can give that carbofuran treatment for the seeds. So seeds should be treated with the 5% carbofurans. So these are all the important seed treatment. Apart from that, regular that azospirillum treatment also we can follow for the sorghum. So that is the important biofertilizer treatment. Then coming back to that fertilizer requirement, as far as that sorghum is concerned, this also agriculture crops, so that should be given with 12.5 tons of the farmyard manure. So farmyard manure 12.5 tons per hectare. Regarding that major nutrients, nitrogen, phosphorus, potassium is concerned, here we have to apply 150 kg per hectare. And basal we have to apply that half of the nitrogen and full dose of the phosphorus and potassium. Nitrogen should be applied in 2 split doses, one at 45 days after sowing, that is first immediately after completion of that weeding operations. Then second, and another 25 kg that should be applied during that fruit leaf stage. In addition to that, if this is a seed crop, so that should be given with a 2% DAP spray during that flowering time. Then micronutrient mixture also we have to supply. So here we have to apply 12.5 kg micronutrient mixture that should be applied in the soil just before that last flowing. Irrigation also we have to ensure, because the seed crop that should not starve for water at any critical stages. So the critical stages are primordial initiation stage, vegetative stage, and milky and maturity stages. And also we have to control that weed population also, or otherwise that weed will compete for all the inputs, so that ultimately leads to reduction in the yield. So here we have to use that atrazine as a free emergence that should be applied 3 days after sowing of your seed material. That roguing operation is very important. So here that Johnson grass, Sudan grass, and forage sorghum that is available nearer to your field, that create a major problem. Particularly that Johnson grass, it's a wild relative of that sorghum that act as a pollen contaminant. But all that Johnson grass and Sudan grass incidents are there in and around your seed production area, you must be very careful, particularly in the hybrid seed production operations. So there you have to adjust that isolation distance until to the level of 400 meter. For variety we are recommending 200 meter. If at all that Johnson grass incident is there in and around your hybrid seed production field, there we have to ensure 400 meter isolation distance both at foundation and certified seed stage level. So if at all these weeds are going to be there within your seed field, you have to identify that one before pollination fertilization of your seed crop. By that way only you can ensure the genetic purity of your material. Similarly, in the case of sorghum, some of the disease also causes major problem like kernel smut and head smut. So we have to identify all these ear heads, that is ear heads affected by the kernel smut and head smut, that should be removed, that should be rolled out. Or as a precautionary measures, before occurrence of these particular diseases, we have to apply appropriate fungicide to prevent occurrence of all these diseases. So these are all the major pest and diseases causing problem to our seed crops, sorghum seed crops, like shoot fly, stem borer, mite. Stem borer normally occur at vegetative stages, later stages, shoot fly in the that seedling stages. And then disease like sugary diseases, downy mildew and charcoal, kernel and head smut, like that, so many things will be there. So to control all those things, we have to give a seed treatment, as well as that the crop should be applied with appropriate fungicide treatment. So regarding that maturity, so that seed will attain physiological maturity on 40 to 45th day after 50% flowering. So at the time that moisture content will be 30%, and like that of maize, here also the tongue layer will be formed. So the point of attachment of the seed with the floral stalk, that is a cob or the head, so a black color layer will be formed. So that is a tongue layer. That formation of the tongue layer clearly indicates that the biological connection between that seed and the mother plant is over. So by the way of seeing or observing that tongue layer formations, we can have idea about whether that seed attained physiologically mature or not. So we have to harvest the crop at physiological maturity. So immediately after harvesting, we have to reduce the moisture content to the level of 15 to 18%. Then you can go for separation of the seeds from the ear head. So normally here we are using that beating with bamboo sticks. And then after that separation of the seeds from the ear head, that should be dried and moisture content to be reduced to the level of 8% for long-term storage. Then we can go for that grading. So for grading purpose, here we are using 9 by 64 inches round perforated metal sieves. So round perforated metal sieves are used for grading of the sorghum seeds. So these are all the field standards. So maximum permissible off-type limit at the foundation stage is 0.01%, whereas certified seed stage 0.05%, like that. So at the end you will have a seed yield of 3000 to 4000 kg per hectare. So that is the thing. And then once that everything is over, cleaning, grading, everything is over, we have to treat the seeds with appropriate fungicide and insecticide. Then you can go for that storage. So that is a thing. And then another thing is there, mid storage correction treatment. We can have a separate discussion on free sowing seed treatment, mid storage correction treatment, and free storage treatment and all. So here you can just note down that chemical name alone. We can have a detailed discussion regarding this one on later. So here for mid storage correction purpose, we are using disodium hydrogen phosphate. So the recommended dose is 3.6 milligram per liter. The duration of soaking also for 6 hours. So with this we are completing that seed production in sorghum varieties. So before that completions, I wanted to give you information regarding the seed standards. So in the case of sorghum, we have to maintain 75% germination. So minimum 75% germinations we have to maintain, and that ODV, that should be 10 in number in the case of foundation seeds, whereas the 20 in number. So this is all maximum. So these are all the seed standards we have to maintain. Then only you can sell your seed as a seed in the open market. So thank you very much. So the next class we can discuss about that hybrid seed production in sorghum.